Hello everyone. So this is third lecture of matrices. In this lecture we're going to discuss Hamilton theorem and matrix method. Okay? So let's start then. So first we'll do Hamilton theorem and then we'll do matrix method, okay, to solve system linear equation. So Hamilton theorem. You check the spelling, it might be wrong. So according to Hamilton theorem, every matrix satisfies its characteristic equation. What is characteristic equation? We're going to discuss. Okay, so don't worry. So first you have to understand every matrix satisfies its characteristic equation. Okay. So the characteristic equation looks like this. Determinant of a minus xi is equals to 0. Okay. So we will take a matrix, and a matrix will be given like take this 1, 2, 3, 4. Now identity matrices, as we all know, that is in form of this, right? Since you know it's a diagonal matrix, square matrix, diagonal matrix. So this the diagonal part, or you can say the part where I is equals to j, the elements will not be 0, and it will be an element, and that element will be same, and that will be 1 for an identity matrix. Okay, now talking about a minus xi, so let's calculate this. A minus xi, so this is looking like, I think, 1 minus x, 2, 3 minus x. Okay, but here 0. Okay, so we will consider 0 also. So like this, I think now we are on the same page. X 0 0 x. Okay, fine. So 4 minus x, right? Now what I said about every matrix satisfies its characteristic equation, you will understand now. Now we have calculated a minus xi matrix. Now we have to just find its uh, determinant, right? Let's find now. X minus 1 into x minus 4, right? And minus 6 is equals to 0. This is the determinant of a mod a, determinant of a minus 6, right? Now just solve this quadratic. You will get like this. Means just expand it, and x squared minus 5x plus 4, and like this. Now this is the equation which you finally get. Okay. Now, as we know, every matrix satisfies its characteristic equation. So here the matrix X will surely satisfy it. So we can write a square minus 5a plus minus 2 is equals to 0. And in this way we will proceed. Now some more thing you have to understand, like this. Now if we pre-multiply by a inverse both sides, what we'll get? You just see. Uh, yeah. So here also pre-multiplication, but it will be 0 only. So I wrote directly 0. A minus 5a into a inverse, that is identity. 5I minus 2a inverse is equals to 0. Are you getting what I'm saying? It is so, you can say, easier to do that. First of all, you have to see the matrix. Then you have to find a matrix that is a minus xi, and then you have to take the determinant. When you take the determinant, you will get a quadratic equation, and in that quadratic equation you have to use the concept that every matrix satisfies its characteristic equation. That is the characteristic equation which you got in quadratic. Now when you will satisfy it, it will look like this. Now after that, if you need to find a in the terms of in the form of A inverse, then you can go by this way, right? So it's quite easier and quite real approach. Okay, I hope everyone has the knowledge of. So very sorry, there was a power cut. Okay, so the light suddenly gone. So now it's okay, I think. I have lighted up there. So like this, we can find the in terms of A inverse also, right? Now, talking about next matrix method to solve system of linear equation. Just see how we can matrix method. We discussed Kramer's rule, that is quite easier method, and we will use everywhere. Everywhere we'll use that method only. This is just for sake of completion of the chapter that we are discussing matrix method. Okay, so just see a1x plus b1y plus c1z is equals to d1, right? a2x plus b2y plus c2z is equals to d2. a3x plus b3y plus c3z is equals to d3. Now we have to just name out three matrices, that is A, X and B, in the following way, right? So A will be like this: A1, A2, A3, B1, B2, B3, C1, C2 and C3. X is like this, got it? And the B is like this: D1, D2 and D3. I hope you got it. I think so. Okay. Now these are the matrices which we defined to understand the matrix method to solve the system of linear equations, right? These are the methods. These methods are useful for your subjective papers like boards, but when we talk about competitive papers, then this method is not so prevalent. Okay, so A, X, and B we have defined. Now the matrix equation says Ax is equals to B. This is our matrix equation. Okay, and just taking A inverse, pre-multiplying with A inverse by A inverse both sides, we will get X is equals to A inverse B, which we can write adjoint of A over determinant of A into B. This will be the X. Now calculating the A inverse, calculate and multiplying it by B, we will get in matrix, and that matrix we will just compare it with the xyz, and we will get the values of xyz, and in this way we can find the values of, means you can find the solutions of system of linear equation which we have defined above. Okay, not above, in previous pages. Okay, now talking about conditions, so infinite solutions for infinite number of solutions, determinant of A must be 0, right? And a quantity called adjoint of A into B, this should also be 0, right? Okay, I hope you got it. Determinant of A is equals to 0, and adjoint of A into B is also, should also be 0, and okay, these two are the mandatory things which should happen. But as I said earlier, that we will prefer Cramer's rule rather than this. Okay. Next, no solutions case. So in this case, simply determinant of A will be 0. But remember, adjoint of A into B will not be 0. Never. Because if it will be 0, then the solution will be infinite. But we need no solution. So for that, determinant of A should be 0, but adjoint of A into B, the product of adjoint of A is a matrix, B is also a matrix, then we will just find the product, and that product should not be equals to a null matrix, that is 0. 0 means null matrix. Okay, that's as simple as that. Now talking about what you say, unique solution, right? A unique solution very easy, as you know, all know. That will be determinant of A must not be equals to 0. Like there we discussed about what? Yeah, uh, determinant of D, where we have defined D, D1, D2, D3, or you say D, dx, dy, dz. So for the Cramer's rule, for infinite solution, D should be equals to D1 should be equals to D should be equals to D3 and should be equal to a value that is 0. Talking about no solution, D should be 0 and at least one of the D1, D2, D3 should not be 0. Talking about unique solution, D should not be equal to 0. And that same more or less follows here also. You can relate from that concept. Okay. So this was our matrix method to solve system of linear equations, and with this hopefully we have completed the theoretical portion of matrices up to what maximum your exams require. Rather than I'm not talking about higher mathematics. In higher mathematics there are so many topics which I also don't know, but there are many topics. Many topics. Matrices are again a very big chapter in higher mathematics. But talking about in this particular, you can see up to the most you can say famous competitive examinations. Uh, okay, this is the most precise and most, you can say, crux of those concepts. Okay. So in next lecture we are going to discuss some of the problems of adjoint, inverse, or whatever we studied so far in matrices, and then we will switch to the next chapter. And next chapter I'm going to tell you right now only. I have decided to start some portions of you may say vector. Okay, I'll start vectors next. Vectors okay next week. This video will also reach out to you in 27th of April. In the week of 27 to 2 May, that week only we'll start vector. Okay, and it will be covered in 3 or 4 lectures. I'll discuss with you in the community post. And again, I have not decided so far about what will be the topic of your, because today I'm recording on 25th. Okay, and I have not decided till now that which chapter I have to take next in chemistry. But very soon I'll tell you. Just give me some the day you will see this video. Till then you will be aware of new chapter, because I'll decide on Sunday, that is tomorrow, 26th, and then I'll let you know. Okay, so thank you so much for joining me in this session. Let me show you the slide of thank you, and then we will just end this session. Okay, so thank you for joining me in this session. Next chapter will be vectors, but before that, one session will come of problem solving. Nearly 5 to 6 questions will be there. 5 questions will be there, in which we will just revise all the concepts. We'll use it in just the concept, the theory which we have studied so far. We'll just apply it in the problem solving in the questions. Okay, those questions will be very good, decent level, and that will help you out. Concept clear. Okay, make your concept clear and just okay then. Uh, so bye bye, take care, and another session in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, thank you so much.